So go to aws.amazon.com and sign into the console, and we're in. The first thing you want to make sure is that we're in the right region. If you recall, when we set up our S3 bucket, we created it in a specific place. And for me, that was the North Virginia data center. So if you need to, change your data center to where you created that S3 bucket. And remember where you are, okay? Now just go into the services search box here and type in EMR. And we will go to the EMR Elastic MapReduce service and actually create a cluster. All right, let's give this cluster a name. It could be anything as long as it's something you recognize it by. Let's say Movie Rex cluster. And we will leave logging enabled. We are going to leave it in cluster mode. That means that it's going to spin up a cluster and leave it running. And at that point, we can log into it and do whatever we want with it going forward. Step execution is different. That can actually launch a predefined set of tests or jobs or tasks, if you will, as soon as the cluster spins up. And then optionally, it can terminate itself automatically when it's done. Let's also select Spark as our software configuration, since this is a course about Spark and I have a Spark jar file that I want to run. All right, here's where things get a little bit niggly. We need to select an instance type and the number of instances. Usually the defaults here are reasonable starting places. Knowing how many you need is a little bit of an art. Now, there's a little bit of trial and error involved here because every job has different characteristics as to the resources that it needs. One thing you can do is try running a subset of the data on your desktop and try to figure out how far you can get on one CPU's worth. And then you can usually extrapolate out roughly linearly to figure out how many instances you would need for a larger complete data set. That's one way to do it. Another way is to just make an educated guess and see how quickly it runs. If it doesn't run quickly enough for you, add more instances at it. Or if it fails entirely because it could not get the resources that it needed at all, you know you need more. Sometimes you just have to do a bit of a binary search to find the sweet spot. The other piece of the equation is the instance type. You can see there are different options here. Usually it's a safe bet to stick with the default here. That turns out to be a widely available general purpose type of machine. Now there is a newer version available, the M4 class as of this recording, that's actually a little bit cheaper and faster. The problem is it's not as widely available throughout EC2. So provisioning that could be a problem for you. I'm going to go ahead and stick with the M3X large just because I know there's a better chance of actually getting that. If you wanted to, you could try the M4X large and save a few pennies, but it doesn't make that big of a difference. Also worth looking at are the memory optimized offerings. The R3X large isn't that much more money. It is more expensive, but it gives you about twice as much memory per instance, and it is optimized for fast memory access. And for Spark in particular, that can be valuable because Spark's entire secret to success is that it is a in-memory solution for the most part. It tries to do as much processing as possible within memory, as opposed to pushing things over disk or across the network. If you have the budget to spare, that can also be a good choice. We're going to stick with the default, like I said, because that's going to be the most likely to succeed. And to save a little bit of money, I'm just going to go with 2 instances because even though 1 million ratings sounds like a lot, it's really not. I could actually do that on one computer without a problem, but since I want to actually run on a cluster, which implies more than one, and I also want to save money, I'm going to keep it at 2 instances. Finally, we need a EC2 key pair because without this, we would have no way of logging in to our cluster once we created it. The security on these things are incredibly tight. You can't just SSH into it and type in your password. No, you need an actual secret key to get into it. To do that, the easiest way is to just click on this handy link, learn how to create an EC2 key pair, and follow the link to the EC2 console. And from there, we can click on key pairs and create key pair, give it a name, Spark cluster perhaps. And you see what happened. It automatically downloaded a PEM file, and this contains the private and public key for my Spark cluster that I will use to log in. Any EC2 instance that I create with this key pair will need that information to log into it. And this is the only time you will ever be able to get that file for security purposes. So make sure you know where that got saved to and keep it around because we're going to need it later and there's no way to get it back. All right, back to the console here. So let's close out of this. And now we should see that as an option for a key pair, Spark cluster. Make sure you select one there. And at this point, we're ready to actually kick it off and create our cluster. Woohoo! Okay, now this is going to take about 10 or 15 minutes to spin up. It has to go out and get the hardware that it needs, install all the operating system and the software that it needs, and then boot it up for both the master and the core. This will take some time, but at this point, we have actually kicked off the creation of an actual Spark cluster. Once this is done, we can actually log into it and do something interesting, actually run our Spark script. So just wait for that starting to change to indicate that the cluster has started up and it's waiting for you. Now remember, the clock is ticking now. The meter is running. This is costing us real money for every hour that we leave this up and running. So how do we actually connect to this thing and do something useful? We want to actually kick off our Spark job somehow, but first we need to connect to the cluster to do that. We need to connect to the master node somehow so we can actually kick that off. But everything's locked down by default. It's all very tightly secure. So we need to punch through that security so we can actually get into it. There's a couple of things we need to do first. One is we need to open up a port for SSH on the master node if there isn't one already, and often there isn't. To do that, go down to where it says Security and Access and Security Groups for Master. Go ahead and click on that link and make a note of the name of the security group. It's Elastic MapReduce-Master. From here, we get a new window with our security groups, and it's the master one that we're interested in. Let's go down here and select the Inbound tab because we want to open up an inbound port for SSH. Hit Edit. And now if I scroll down and say Add Rule, I can add a custom TCP rule, but I want that to actually be SSH on port 22. And here's a neat little trick. Since I'm going to be logging in from this particular IP address, I can just say in the dropdown, my IP, and it will automatically figure out the IP address of my home here where I'm connecting from. Hit Save, and that should at least make the SSH port accessible to me, to my IP address, to nobody else. It's opened up in a very secure manner at this point. Now, the next thing we need to do is actually SSH into it, and if you click on the SSH link here, it will tell you how to do that to some extent. Let's start with Linux, and we'll show you how to do Windows next. Under Linux, the key is to copy this hostname here. That is the externally facing hostname for our master node. So I'm going to copy that to my clipboard. These instructions aren't entirely complete, so let me show you what you really have to do. Let's go back to my Ubuntu desktop here in my office, and I'm in my Spark AWS folder that I'm working within inside my home directory. And you can see I've already downloaded the spark-cluster.pem file. That is the key file with the public and private key for the cluster that I created it with. Remember, when we spun up the cluster, we created a key pair file. That was the PEM file that we got down there. Now, we need to make sure that has the proper permissions. So to do that, we can say chmod 400 spark-cluster.pem, and that will ensure that that has the necessary privacy on it to make the SSH command happy. Now we just say ssh-i and a path to that PEM file, and then we will paste in that host name, right-click in this particular client, and that should get us in. Sure enough. Yes, I'm sure I want to connect. And we're in. We're on our master node. Awesome. Now let me show you how to do that in Windows as well, because that's a little bit tricky. Now in Windows, we need to use a tool called PuttyGen to convert that PEM file, that PEM file, into a PPK file. So if we go to Putty in our Start menu here, we should be able to find that application. Under the Putty menu, we want to find PuttyGen. So let's open that up. Let's load up that PEM file that's in our Downloads folder. And we need to change the filter to all files because it doesn't see it by default. See what I did there? Change the filter to all files and then selected our PEM file that we created and downloaded earlier. Okay, that's great. Now we say save private key. Actually, I do want a passphrase. Type in any password you want, and that way we'll prompt you for it whenever we try to use this key to log in. And we will call that spark-cluster.ppk. All right, so we can close out of that now. And now we can use that PPK file to log in from the Putty utility in Windows. If you look back to the instructions here for Windows, it does give you a handy download link if you don't already have Putty, but if you've been logging into Linux systems from Windows, you probably already have that. From here, we still want to keep that host name in our clipboard, so let's go ahead and copy that again. And let's open up a new client, paste in that host name. We want to go to the SSH category here, open that up, and then click Off. And from here, we want to browse for our PPK file. Now that's in our downloads is where we save that. All right, and that should be all we need. Yes, that's fine. And now it's going to prompt for that passphrase that I associated with the key, and we're logged in from Windows as well, directly. There you have it. We are now logged into the master node of our cluster from both Windows and from Linux, and from here we can start to actually put it to work. All right, at this point we are logged into the master node of our EMR cluster successfully, so let's put it to work, shall we? Now we need a couple of things. Remember, we preloaded into S3 in your custom bucket both the jar file for this actual script that we're going to run to produce movie recommendations and also the movie lens dataset itself. And the script expects to find the movies.dat file right here so it can map movie IDs to movie names while it's outputting the final results. So let's take care of that. Looks like we have them both. We have our jar file that contains the Java bytecode of our Spark driver script, and we have the data file that maps movie IDs to movie names. So let's rock and roll. You're going to be amazed at how easy this is. The beautiful thing about EMR is that it has everything pre-installed for you to actually take advantage of the entire cluster that you set up. You don't have to waste time configuring things. The default configuration is going to be a very reasonable place to start. All we have to do is say spark-submit and then the name of the jar file. That's it. Now my script doesn't expect any parameters as input, so I don't have to type anything else. And I also don't need to specify a bunch of parameters for tweaking Spark's memory usage and what servers it's using and all that nonsense. It will just work out of the box. Let's kick it off and see what happens. You can tell from the info messages what it's doing at a lower level. It's actually going to start spinning up executors and kicking off the job. Now remember, the script in the course was hard-coded to use my specific S3 bucket for the movie's data file for the actual ratings. So make sure that you actually change that to your own if this doesn't work, because I can't promise that will be up forever. Well, it looks like it's already printed out the ratings for our fictitious user. If you remember, user ID 0 really loves Star Wars and Star Trek and old 50s Hitchcock movies, doesn't like the Rocky Horror Picture Show, and based on that, it chewed on over 1 million ratings to produce these recommendations for me. It says that I would really like Forrest Gump, Braveheart, The Shawshank Redemption, Raiders of the Lost Ark, Star Wars Episode 6, and Star Wars Episode 5, which are both incredibly reasonable recommendations for someone who liked Star Wars Episode 4. These are pretty good, actually. Given that these ratings kind of reflect my personal tastes in movies, these sound like pretty good recommendations to me as well. These are all movies that I've either seen and enjoyed or want to see. So it worked. Pretty cool stuff. There you have it. We actually ran movie recommendations for a real person, me, on a cluster of, albeit 2 machines, but it's still a cluster, running Apache Spark. At this point, I updated our previous cluster that we used to actually work with our cluster interactively, and we had successfully generated movie recommendations based on 1 million movie ratings, which is pretty exciting. Now, do remember to terminate that cluster. I already took care of it here by hitting the terminate button, and you can see that it is terminated, meaning that it is no longer billing me for its usage. Again, do not forget to do that when you're done. Let's do this again, but do it a different way. What I'm going to do this time is use steps on this cluster in order to automatically execute all the stuff that I did by hand by logging into it. That way I can set up a repeatable set of steps that I can actually run over and over again if I want to. And the beauty of it is that I can tell the cluster to spin itself up, go run the code that I want to run, and then automatically shut itself down and terminate itself once it's finished. So let's see how that works. Hit cluster list to go back to our cluster list, and we can see the earlier one that we created and shut down. And we'll hit create cluster to make a new one. Let's call this one Movie Rex Steps. Okay, now this time we're going to select step execution. And this lets us interactively create a bunch of steps that we want to run automatically. Now, if you remember, we basically did 3 things when we ran it by hand. We copied down the jar file with the code that we wanted from S3. We copied down the movies.dat file from S3 as well, and then we kicked off the Spark job itself. Now, in order to issue arbitrary commands like copying stuff from S3, we can use a little custom jar out there that lives in S3 that will let you run arbitrary code as a step here. So let's say custom jar is our first step. Let me show you how that works. The jar location is going to be this, S3:/ elastic map reduce / libs, and this is a publicly accessible S3 bucket that Amazon provides, /script-runner /script-runner.jar, just like that. And we're going to need this again, so I'm going to go ahead and copy that to my clipboard. And for the arguments, it will be the script that I actually want to run. So what we're going to do is say /usr/bin/hdfs dfs-get. Now, the hdfs command can actually retrieve stuff from S3 on EMR, so we're going to use that as a way to copy down our data from S3 to our local file system. S3:/O'Reilly-fkane. Substitute your own bucket name there, please. /als movie rex 1m_2.11 m-1.0.jar. Again, substitute your file name there if you need to have a different one. And we will put that in the home directory for the Hadoop user, /home/Hadoop. Now for action on failure, we're going to say terminate cluster, because if there's an error, we don't want this cluster to keep living on and charging us money. We want to just terminate itself, and then we can look at the forensic evidence of the logs later to figure out what happened. Let's double check everything there. Looks good. Hit add. Now the next thing we need to do is copy down the movies.dat file, and that will work in the same way. So we're going to create another custom jar step, paste in that same jar location for the script runner jar. And this time the command will be /user/bin/hdfs dfs-get s3 : O'Reilly-fkane. Again, substitute your own bucket there. ml-1m/movies.dat, and that will go also into home Hadoop. The action on failure should again be terminate cluster. Finally, we will actually kick off the Spark job itself, Spark application. We want this to run in client mode because I want it to run on the master node itself, because that's where I downloaded all the dependencies to. For these Spark submit options, all we have to do is say --class com.o'reilly.sparkaws.als movie rex, which is the fully qualified name of the object inside our Spark driver script. And for the application location, we will just say /home/Hadoop/als movie rex 1m_2.11-1.0.jar. That's where we downloaded the jar file to from the previous steps. And that should be all we need. Again, the action on failure should be terminate cluster. We want it to just shut itself down if there's a problem. We'll look into the problem later. All right, double check everything. I think it looks good. And now we can kick it off. But automatically figured out based on the fact that I had a Spark application step that I want Spark installed, so that's good. It also retained my previous settings for hardware configuration, but definitely double check that. 2 M3X larges is perfectly fine for what we're doing. Default permissions are okay as well. And note that we don't even need to specify a key pair, because since we're using steps, there's no need or even reason to log into this cluster directly. It's going to be doing all of its work internally, and we don't need to poke around there to see what's going on. Create cluster, and it should just do its thing. Again, this will take about 10 minutes to spin up, so we will allow the passage of time here and come back once that's ready to go. Time has passed about 6 minutes, it turns out, and you can see the cluster has spun up, and it's actually running my steps right now. And you might have to hit refresh to actually get the latest status here. If you scroll down, you can get a little bit more insight into what's going on. If you open up the steps section here, you can see that it's successfully executed my custom jars to copy down the jar file and the movies.dat file. And right now it's running my Spark application itself, and it's been going for about a minute, so I suspect it's probably almost done at this point. If we hit reload again, it might show that it's finished. Yep, sure enough, it's terminating and the steps are complete. We actually ran our Spark job automatically and automatically shut the cluster down as soon as it was finished. And if we go back to the Spark application step here, we can click View Logs. And from here, we can see the standard output. Sure enough, there's our results. So pretty cool. There you have it, another way of using EMR, this way using it completely automated, using steps to both copy down any dependencies you might have and kick off the Spark job itself, and then automatically shut itself down after it automatically did all that as soon as it possibly could. That's pretty awesome. It's a very efficient way of using your cluster, in that you can just spin it up for exactly as long as you need. Now again, in this particular instance, it didn't really save us anything because you're billed for a minimum of 1 hour anyway, but for larger jobs, it's a very useful thing to have. And it's also powerful in that it allows you to repeat that cluster and recreate it and clone it as many times as you need if you need to run this job again. Is that the default configuration that it sets up on your cluster for you is usually pretty good. It's a good place to start with, so you don't have to waste a lot of time tweaking configuration settings necessarily. It has a feature called dynamic resource allocation even that tries to make the most of the hardware that you have available. But sometimes you do need to tweak things. Maybe you want to fine-tune the usage that each executor has of memory or whatnot, or you want to fine-tune how much memory your driver script is taking. There's a lot of little tweaks you can do to try to squeeze a little bit more bang for the buck out of your cluster. Often you will want to adjust things a little bit. And there's a bunch of ways of doing it, so let's talk about the various ways, and some of them are specific to EMR. The first thing you can do is actually specify your configuration settings in the script itself, and if you do that, it will take precedence over anywhere else where you might have configuration. For example, if I were to do something like this, .master local2, this is a common thing to do when you're testing out your script on your desktop because it forces your script to run on your local PC in standalone mode using no more than 2 processes, so you can uncover any issues that might be specific to parallelism. However, if you were to forget and leave that in when you uploaded this script and made the jar file for your cluster, you would force this script to run only on that driver node, on that one PC, using no more than 2 processes, because that configuration takes precedence over everything else. If you were to mess up and leave that in, you would not be making use of your cluster at all, and that would be bad. Instead, you would either want to leave it off or leave it on yarn before you upload it, specifying that you want to run on your yarn cluster instead. You can also set arbitrary config settings here as well. For example, .config and name of the configuration setting, spark.eventlog.dir. Let's change the event log to go somewhere else, for example. So you could do it like that. Basically, any config setting for Spark can be set explicitly this way within your script itself. So that's one way to do it. And if you specify this in the script, again, that takes precedence over any other config settings that there might be on your system. Now, the next level down is actually the parameters on Spark submit when you're actually kicking off your job on the cluster. For example, imagine that I'm logged into the master node of my EMR cluster, and I want to kick off a jar file that I have for Spark. I could say spark-submit. And now I can start to do some command line parameters to override what might be on the cluster's configuration itself. So for example, I could say --master yarn if I wanted to force it to be on yarn, although that's what it's going to do anyway. More interestingly, I could do something like this, --executor-memory 2G. That would say, I want each executor to have 2 gigabytes of memory allocated to each process. That can be important if you're running out of memory when you're trying to run your job. So sometimes you're kicking off a Spark job and you'll get a bunch of out-of-memory errors and your job will fail after a while. And sometimes you just need to manually increase that amount to get it to run reliably. That's okay. And you can also set arbitrary configuration settings on the command line as well using --conf. For example, --conf spark.eventlog.dir equals hdfs://spark/event-log. The syntax there is --conf quote name equals value. And then I'd finally obviously give the name of the jar file itself and kick it off. That's the second way to do it. Now again, any configuration setting that's in the script itself will take precedence over what you put on the command line, but what's on the command line takes precedence over the configuration settings on the cluster. Let's say you want to actually control the configuration settings on the cluster while you're setting it up. That seems like a reasonable thing to do as well. Now to do that, we're actually going to get into the realm of EMR specific things. Let's say you're creating a new cluster in the console here. You would just click the Create Cluster button here and go to town, right? But if you want to override settings, you want to go to the Advanced options, and this will give you the chance to do so. Here we need to specifically select what software we want. So for example, I'll want Hadoop and Spark and not much else. Maybe Zeppelin. I might use Zeppelin. And here you can edit any configuration that you want. And it's not limited to Spark. The syntax here is a little bit tricky and important to get right. First, you have to say classification equals config file name. And in the case of Spark, that's going to be spark-defaults. And then comma properties, and then in square brackets, the actual key value pairs for the configuration settings that you want to set. For example, let's say we want to override the executor memory setting again, like we did on the command line. We could say something like classification equals spark-defaults, comma, properties equals bracket spark.executor.memory equals 2G, close bracket. If I were to go ahead and finish configuring and creating this cluster with that in place, it would have an explicit executor memory size of 2 gigabytes. Now let's say you don't want to type this in every time that you actually spin up a cluster to launch this particular job. You can also load JSON format config overrides from S3. For example, I have already uploaded to S3 one of my own files here. It's under a bucket that I called sundog-spark, sparkmaxalloc.json. This way, you can put your config overrides that you want for your cluster in a JSON file, upload them into S3 somewhere, and all you have to do is put that file in to refer to it whenever you create your new cluster. For example, here's what that file looks like. This one is actually setting a special classification called Spark as opposed to Spark defaults because this is an EMR specific setting for Spark, maximize resource allocation. In this example, we're looking under the Spark classification and we're setting the property maximize resource allocation to true. And this specific property is worth talking about a little bit as well. It's an EMR specific setting that says, I want each executor node to use all the resources available on the computer that it's on. Now, that might sound like a very tempting thing to do. Wow, I'm going to make full use of all the resources I have. But in reality, that could be a very bad thing to do because maybe your executors don't need all those resources. And in fact, you could have run many more executors on a certain machine if you didn't have that on. But if you're running into a lot of resource allocation problems, then this might be a good thing to try out just to try to get yourself going. Remember, what this does is it maximizes the allocation of all resources on a computer to one executor. This does not mean that you're making the best use of your resources. By default, EMR will do that for you anyway. So use this setting wisely. But that's an example of how to use a JSON file to actually store configuration overrides for your cluster. All right, those are the various ways in which we can override the configuration on your cluster. We looked at setting it from within your script, from the command lines on Spark Submit, and using the AWS console as well. So those are all different ways to do it. And hopefully you won't have to use them very often because, like I said, the defaults are usually pretty good, but this level of tweaking is there if you need it. Spark and Hadoop offer a bunch of web UIs that make it very handy to see what's going on with your Spark jobs and also to interact with Spark throughout a notebook interface. You see all these little tempting mentions here of Zeppelin and the Spark history server and the resource manager, but we can't actually get to them. The reason why is because the security on your EMR cluster is really tight, and there's no way to actually connect to it through the web by default. What we need to do is actually set up an SSH tunnel to your master server and then use a proxy from your web browser to actually go through that tunnel and connect to the web servers that are hosting these different pages and interfaces to interact with your Spark cluster in real time. It's a little bit of extra work, but it can be worth doing. In this example, I've spun up a new cluster already, and it's sitting there waiting for me to do something with it. But before I can actually interact with the history server or the resource manager or Zeppelin, I need to enable a web connection. And you're going to have to click on this little link here because it will have specific information that is unique to your cluster that you just set up. All we really have to do here is follow the instructions for opening the SSH tunnel. Now, when we configure the proxy management tool in step 2, there are a few little tricks to that I want to show you. Let me just walk you through the whole process here. You can see there's a lot more to it on Windows than Linux. If you're on Mac or Linux, all you really have to do is enter this from your command line, just copy and paste it in, and you're done. You have a tunnel up and running at that point. On Windows, since there's no really built-in SSH command in the operating system, we have to use PuTTY instead. So let's focus on that because that's a little bit more tricky. And again, if you are doing this from Linux, make sure you do copy and paste that exact line. The actual port and the actual host name here is important, and it will change depending on what cluster you're actually working with. Under Windows, it tells you to install PuTTY. Fine, we already did that for earlier stuff that we did. Let's follow along here. I'm going to pull up PuTTY, and it says I should, in the category list, hist session. All right, I'm already there. And the host name, I'm going to copy and paste this in, which is the external DNS entry for my cluster's master node. And we're going to go to the category list and go to connection SSH auth, just like we did before, and browse to our PPK file that we created earlier for the Spark cluster. And finally, under SSH, we will click on tunnels and say that we want to run on port 8157, which is what it's telling us to do here in the instructions. We will select dynamic and auto. Then we will hit add. All right, hit open, say yes to the security alert, and we have to enter the passphrase that I entered on my key. And now we are in with an SSH tunnel to our master node. Next thing we have to do is set up a proxy in our web browser so we can actually connect to it. If we open up this step, it tells you what to do. And the instructions here aren't really quite right. It tells you to go to getfoxyproxy.org downloads, but if you do that, it's not really clear what to do. They try to get you into this paid program where you're actually paying for an actual proxy server of their own, but that's not what we want. All we want is the Chrome extension to let us configure the proxy settings on our browser more easily. So let's close out of all this. Instead, we just want to do what it says here. You see there's different instructions for Chrome and Firefox. I'm a Chrome guy, so let's go through this. Don't click on that link. Instead, go to the settings in Chrome and go to settings. And from here, click on extensions. And from here, go to the bottom and say get more extensions. Now we can search for FoxyProxy here. And you can see there's FoxyProxy Basic. That's fine. Let's use that. Add to Chrome. All right, FoxyProxy is installed, and you can see that they really don't want us using the free version, but whatever. That's what we want. Now, if we go back to the instructions here, we can see that we want to create a text file that contains exactly what's in here, and this is specific to your cluster. Let's go ahead and copy all of that, and let's open up WordPad or something. Paste it in. Looks good. And give it some arbitrary file name. EMR FoxyProxy. How about that? And we want that to be a text file. Now, we need to go to the FoxyProxy itself and import that setting. So let's go to Options, Import Export, choose a file, and we'll go to my Documents and open up that file. Add. Okay. Our settings have been imported successfully. Woohoo. We're almost done here. All I need to do now is actually activate FoxyProxy itself. And I can click on that link and say, use proxy, EMR SOX proxy, or default. EMR SOX proxy is the one that we want. Activate that. And now we should be able to actually connect to these UIs. So if we go back to where we started from, we can see that these connections are now active because EMR has sensed that we have a tunnel active and we can actually connect. So let's look at our Spark history server now and see if that works. Sure enough, there it is. Now, I haven't actually run anything on this cluster yet, so there's not a lot to see, but if I did, you would see the history of those jobs here, and I could actually interact with it and look at the DAGs that actually constructed the execution plan for that job and whatnot. We can also look at the resource manager for the cluster itself. Cool. So there you have it. And more interestingly, we can also open up Zeppelin to actually interact with our Spark cluster in real time, but we'll save that for another lecture. There you have it. We now have a tunnel up and running to our cluster so that we can interact with all the various web UIs that are associated with Spark and with Hadoop.